Cam, you ready?
Yep.
Okay.
Uh-oh, lost somebody.
Who left the building? What did I do? Dylan.
Y'all got it or no?
Sir?
Y'all don't have it, do you?
No, sir.
The share screen.
Pick your screen.
All right. Hold up.
You're having some technical difficulties there, buddy?
Of course.
No,
Is it a YouTube?
Yeah.
What's the name of it?
Oh, hold up.
Okay, I'm holding it up.
Electrical rubber goods, blankets, line hoses, covers, testing and inspection.
That's a long description, so hold on one
Just
second.
look up Lyman rubber blankets.
Lyman rubber blankets, will do.
Just look up that and it should be the first one.
Okay, give me a moment so I can get there, okay?
I got
10-4. Lynenan, rubber blankets,
you. Yes, sir.
stand by. It shows a guy on a screen here and it's got a LTL in the upper right. Is that the one?
Yes, sir.
You sure?
Yep.
Okay, stand by.
White dude with glasses, kind of looks like V.
wait a minute.
Yeah, you're 100% correct.
Yep, that's him.
All right, stand by.
You got my sideline, huh?
Mhm. Excuse me. Is that the one we want? Hello?
I'm not seeing it yet. Oh, there it is. Yeah, that's it.
That don't look like me. You crazy.
Production manager at Lyman's Test and Laboratories. Today we'll walk you through the steps for inspecting your blankets, line hose, and covers when in the field. We'll also review the steps taken when your equipment arrives at LTL for annual service. When working in the field, you need to feel confident that your PPE is performing as intended for the protection against accidental contact with energized apparatus. To ensure the electrical integrity of your PPE, it is important that you properly care for and maintain the insulated equipment. At LTL, our certified factory-trained technicians provide the proper inspection and testing of your equipment to ensure your safety when on the job. Before we start, I wanted to talk about our NAIL accreditation for what that really means. NAIL for PET stands for North American Independent Laboratories for Protective Equipment Testing. As advocates for safety in the workplace, LTL is represented on the NAIL Board of Directors. NAIL is a nonprofit organization that helps develop uniformity in testing, working in close association with ASTM and ANSI. To maintain accreditation, regular audits are conducted to ensure all industry accepted standards are adhered to. Independent testing facilities operating without NAIL accreditation are not monitored to ensure industry best practices and standards are followed. To learn more about the difference between certification and accreditation, please visit our website at ltl.ca or contact your local LTL product specialist. As a NAIL accredited certified laboratory, we inspect and certify insulated blankets, line hose, and covers per applicable standards. PPE is to be inspected and tested annually per ASTM F478 and ASTM F479. When your PPE arrives at LTL, the equipment is checked in and recorded. It is then washed with a mild detergent and water and air dried. Electrical test is performed on blankets per ASTM F479 and the line hose and covers per ASTM F478. When the test is complete, the lab technician moves the PPE to final. When in final inspection, blankets are inspected for punctures, cuts, corona cutting, and any obvious condition which would adversely affect the performance as per ASTM F479. The technician rolls the blanket over itself and on both sides to view all surfaces in search of cuts, foreign matter, ozone checking, dielectrical breakdowns. If any of these conditions are found, blankets are rejected. The technician circles the area with a black marker and writes the description of the defect and stamps the blanket with a defect stamp. Blankets passing visual inspections are stamped with an expiry date indicating next annual inspection and testing. Blankets are placed on a sheet of craft paper and rolled no more than 6 blankets per roll. Defect blankets are rolled separately. The outside of the paper is taped and marked with the customer name and work order number and the number of pieces. The interval between date of issue and retest shall be based on work practices and or company policy, but shall not exceed 1 year. When inspecting the line hose, the hose is opened up and bent backwards and then forward the entire length of the line hose. The lab technician is looking for foreign matter, deep cuts, mold defects, chemical breakdown, and dielectrical failures. Insulating line hose and covers are inspected for punctures, cuts, severe ozone cutting, holes other than factory produced openings on the top sides or lips of the line hose or covers, tears and punctures, serious cuts, and rope or wire burns that extend more than 1/3 the depth of the thickness of the rubber per ASTM F478 section 11.7.1. Texture changes, swelling, softening, hardening, and becoming sticky or inelastic. Other defects that damage the insulating properties and that would adversely affect performance. When leaving LTL, all your equipment is returned in near new condition. When in the field, it's the user's responsibility to properly care for and inspect equipment prior to each use for your protection from electric shock. Blankets, line hose, and covers are to be inspected visually for defects before use and at other times if there's reason to suspect any damage using the same inspection process as that we use. Be sure to remove any oil, grease, or other damaging substance as soon as possible. Use only a mild detergent if necessary. It's important that blankets, line hose, and covers are stored in a bag, box, container, or compartment that is designed specially for them and in a location that is cool, dark, and as dry as possible. The location shall be free from ozone chemicals, oils, and away from electrical discharges and sunlight. If you suspect your equipment is defective, remove from service and send to LTL, accredited certified testing facility, for your further inspection and testing. By following these steps, both in the field and in the lab, your PPE will be ready and safe to use. For questions, please contact your local LTL product specialist. And thank you for watching. Have a safe day.
Good video.
Yep.
Good video. Anything you'd like to add?
They're cracked, thrown away. I mean, make sure nobody else is going to use them after you, and they're there for a reason to protect you. So that's it.
That's a very good point. And I know I did this back in my younger years, and the company did this also, especially on a blanket. You know, we're sometimes a hose. If you found a defect in a blanket, and you notice by the video right there, they just had a little pinhole in it.
Mhm.
See if I can- Here you go. Oh, I thought it was just on it. There you go. They'd have a pinhole in it like that. Well, is the rest of the blanket okay?
Yeah, but it can't be used.
Can I cut it? Can I cut it up and make smaller pieces of blanket?
No.
You're correct. You're 100% correct, but I guarantee you, if this was down towards the corner of a blanket that I already had back in the younger years, much younger years, we just cut that piece away and we use the rest of the blanket again. You don't do that anymore. As soon as you get a defect in one spot, you throw the entire blanket away, and make sure you throw it away. Don't let it ride around in the back of the truck or the back of the flatbed or wherever you're going to put it. Go ahead and get rid of the whole thing. What else? Anybody, anything more you'd like to add?
Yeah, we especially the blankets, before we used them each time when we were rubbering up the top of a pole, you know, to do some hot work, we always had to roll them from corner to corner to check for cracks that way, because even if they came back new from the test lab, don't mean they're 100%. You need to check that stuff for yourself.
Right, right. Guess what color this hose was when it was installed?
Wow.
Orange.
Orange, yeah. When he was talking about, and you heard there's certain types of damages that can happen, that's ozone damage. Well, ozone damage comes from having the hose on the conductor for an extended period of time. It's both solar and atmospheric damage that happens to a rubber hose out there in the world. You see one in this type of situation, you got to get rid of it also. Now, our rule, Professor V, was you were not allowed to leave rubber on overnight.
We did in certain circumstances. If we were covering up for like somebody was crossing our lines or something, we left them in there, but not for an extended period of time.
Right. So I'm going to throw a question out there in the world. If I've got all my conductors, and this is what you're seeing here is especially used in a lot of overhead situations. If I got all my conductors covered up with blankets and hoses and hood covers, and there's just multiple types of pieces of rubber that you can put up there. Can I take my rubber gloves off?
No.
No, no. It's just a protective barrier. You still have to work with your rubber gloves and your rubber sleeves out there in the world. So this is just another measure of protection. And you guys remember, through your careers, rubber gloves are your protection against electrical shock. Nothing else is. Even though it's there and exists. You've got a fiberglass boom on a truck, bucket truck, got a fiberglass boom on a line truck, you've got rubber goods on. Your personal protective barrier is rubber gloves. Now, how often do they need to be inspected?
Before every use.
It's good just to give it an eyeball. You know, you're pulling some hoses out, and I'm kind of okay with this too. If I get to a job site and I start pulling out some rubber hoses from the truck or blankets or whatnot, and I give them a look over, they look good, I'm pretty good for the day.
Yeah.
Thank you, Professor V.
Right. Absolutely.
Pretty good for the day. Now, be totally, I can tell you one thing, these things are grossly expensive.
Yeah.
Right? You get up there and you nick it with a knife, or it gets cut on the edge of a bolt, or a piece of copper wire will cut hard. If it gets cut on that, replace it, tell the guy on the ground, hey man, I cut this up, and I can guarantee you're not going to hear any flack from your supervisor, your crew supervisor, or the people in the warehouse. Hey man, you're going blankets like candy. All right. If it's defective, don't worry about reporting it.
Yeah.
Anything else going on in here? Oh, he showed in the beginning up here where he's doing the testing and inspection. What did they do to verify that? They stamped it, right? Check the date that it's been stamped, and if it's within the year, you're good to go. If you have a non-stamped piece of rubber good, and they stamp the rubber hoses too, if it's not stamped or is outside the period of 1 year since it's last been tested, don't use it. Send it back.
Yeah.
Now, Professor V,
Nope.
we did our rubber goods internally, our own organization. Santee Cooper tested our own line hoses and rubber goods. And what we had was once a year, a big old crate box would come up, and we'd swap out everything we had in our fleets,
Same thing.
stuff that was in the crate box. How did y'all do it?
Same thing. Everything came in a big, they got these big, almost like stainless steel crates that came in, and everything was packed and dated and ready for change out.
Okay. There's going to be times, and it's just going to happen. you're going to get in the rotation of rubber goods, which really means you have one set that you're working with in your service center, and another set is down there. You have two sets of rubber goods. And like I said, this money could add up quickly.
Yeah.
If you're sending a set down to get tested wherever it needs to go, and you're short on rubber goods on your truck, let your supervisor know, because some of these are going to get failed. And you're the person that's supposed to keep the stock up as far as the rubber goods are on the truck. They are stocked in the warehouse.
Yeah.
So you send down 10 hoses and 7 come back good, you're -3, correct?
Right.
Don't ride around and say, well, 7 will be enough for me. All right. Get the other 3 from the warehouse, charge out 3 brand new ones. Keep that stock up correctly. Any other questions out there?
The last comment I'm gonna make about it is when he talked about in there about keeping them clean. When you're like covering up like the cross arms you guys are working on, and of course, you know, you can't get hoses on that, you have to cover up with blankets. We have what they call clothespins that hold these on the poles and all on cover up. And if you run out of clothespins, and it's so easy to grab a roll of tape and tape up that blanket or whatever, that, well, we got to the point where they said, you know, don't do that anymore because it's making the blanket dirty and it's could cause you know, dirt and all get dirty and track over. So you want to stay away from the tape. We did it for a long time, but then they, just like in that picture there, you see the yellow clothespins that's holding the blankets on. You really don't want to use that tape because that sticky side of the tape will, you know, leave a little residue on the blanket or even a hose, and it could cause it to track over.
Okay. I'm liking this picture a lot. I don't know what these guys are doing. Looks like they might be you can
Changing that pole.
change out a pole. You can see the one on the left here, that's the new, and the one on the right, that's old. They're doing a pole change out. But guys, this is a good bit of cover. And Professor V,
Yeah.
how long do you think this would take?
Ooh, to cover?
Yeah, just to cover. You got primary also.
It takes extra time to do all that stuff, you know.
Yeah, I would say with these two guys here, you're probably looking at a good 30 minutes
Yeah.
just to get your cover in.
Yeah.
Okay. Take all the time you need, put as much cover on as you think you're going to be in the work zone area of. But there is one missing component here that we had to cover up also. I think Professor V notices it also.
Right.
What was that? What would that be, Professor V?
Your communications and
Communication. Okay. They have, as far as the utility is concerned, and this is secondary, the neutral 120, 120. So they have the secondary wires covered up. They've got primary wires covered up. You're looking at about 1, 2, 3, I'd probably say 4 hoses over here.
right.
But there's one conductive component that's not covered up. What is it?
Yeah. Communications.
Communications. That's a steel wire that runs down through there, and then the communication lines are attached to it. Both go in this direction and coming off the pole in this direction also.
Yeah.
You have to prevent, not only, take this in consideration, remember it, you have to take into account not only the energized conductor, but what else?
Yeah.
energized.
De-energized one too, okay? You have to prevent the complete path. If the guy was to come in contact accidentally with an energized conductor in the bucket like this, we'll say this is 120 volts, nothing's going to happen to him. All right. If he comes in contact with 120 volts and the neutral, that makes a complete path. So cover up everything.
Everything.
Uh-huh.
Yeah.
Okay. Any other questions there?
One more thing. He said he was talking about storing them all in one place.
Mm-hmm.
That's another point, because if you store them with other tools and stuff, something will always puncture it and mess them up.
Yep, great comment right there. We had 2 dedicated bins on our trucks, and you'll get into an organization that sets up their line trucks and bucket trucks to where if I was to come off one crew and go to another crew, and we kept our rubber goods on the long been on the driver's side on
Yeah,
all trucks. You did the same, Professor V?
absolutely.
Yeah, yeah. So you have a standard for all your fleets as
Mhm.
far as where the tools are, where your material is, where your connections are. So everybody would know, I need 3 rubber hoses. They know where to go right away. It just saves time. He did emphasize this, and I've seen this happen before. And this is, we've said this before about rubber gloves. What kind of solvents or what kind of chemicals do we use as far as linemen are concerned? What runs a chainsaw?
Yeah. Yes.
Gas, oil?
Gas.
Okay. What do you glue? Well, I just said it. What do you put conduit together with?
Glue.
Glue. Okay. You got to keep a barrier between that and those solvents that you're using out there. Cable cleaner is probably one of the worst. Between your rubber and that, even not any kind of physical contact, even the fumes will deteriorate your rubber goods and make their life a lot shorter. Now, can you clean your own? Say I got some dirt on it or mud or some grease by accident. Can you clean your own?
Using a proper solvent.
Yeah, sure. And you use a little common sense here. You see those commercials on TV. What do they wash ducks with?
Dawn, so
Dawn. Dawn. Okay. Yep. Get you a bucket. Get you a little bit of Dawn. Put it in there. For one thing, it cleans them great, and the other thing is it's not damaging to the rubber good. Okay. All right. If there's no other questions on that, stop that share. Okay, I'm going to open it up a little bit here because we still have some people that are going to be doing transformer bank wiring on Thursday. And then we're going to get a big conference room, and we're also going to do what we call three-phase bank transformer simulations on a transformer simulator. How are we feeling about closed delta, open delta, and Y banking? Don't be shy. If you're still not comfortable, with it, please let me know.
Feel pretty good about it.
You're what about it?
Yes, I feel pretty good about it.
Okay. Anybody else?
I feel good about it.
Okay. Okay. Well, the door is open right now. If you need some more description or more instruction, more detail on that portion, please do let me know. All right. So with that, I'm going to move over to, and we've talked about this before. Some of you guys are working on this. Am I still on a share here, Professor V?
No, sir.
I'm not sharing.
No, sir.
Okay. Hold on. The importance of getting down the extension stick when you're using the extension stick.
Got it.
All right, stand by. Let's see if I can move this away. There you go. So I'm going to go by Professor V's work practices at Duke Energy and what we did at Santee Cooper also. So an electrical storm destroyed the transformer, full replacement. All right, so typically what happens in situations where in the daytime, nighttime, whatever, a call is going to come from a dispatcher. The dispatcher is going to get probably a computer notice that the call center says a customer's called in with power out. Who do you think they send? The entire crew or just one person?
First responder first.
Yeah, first responder first. Usually that's a line technician A. Sometimes he's alone. Sometimes he has a partner with him. But what kind of fleet does he drive?
Just a work truck.
Yeah, service truck. And Professor P, if you could, while you're sitting there, get a service truck ready.
Yeah.
So he's going to go out. He's going to do an initial inspection, and he's going to look up this pole. And what does he see?
blown fuse.
A blown fuse for one. Okay. What else is going on? And here's the fuse actually hanging out.
Switch is open.
The switch is open, so we know we have power off.
The transformer looks burnt.
That's actually just a little bit of rust. Now that
Oh.
That'll happen if a transformer goes into overload. Okay, it's going to get hot. That is right where the core is at. So it's getting hot and cool, hot and cool, hot and cool. Okay, that's rust. Now, if this was black and you saw some paint peeling, that's another point of concern. You also see little bit drips of rust that are going on down here. Also, that's just rust. Okay, still not time to change it out. What's this piece of wire hanging right here?
It's your ground
Ground to what?
from your.
Got a
Blow up the
switch.
screen a little bit.
What's this thing right beside it?
The switch.
That's the
Where's
switch.
that coming from?
Okay, we
Your
usually
lightning arrestor?
lightning arrestor, exactly. So he's had a lightning strike here. It has actually blown the ground off the lightning arrestor and blown the fuse. Now, that's not to say in this situation, I need to restore power as quickly as possible, but I don't have a bucket truck. All right. What you're going to do here is you're going to go ahead and restore power and report back to the dispatcher that you're going to need a lightning arrestor changed out to this location so they can send a crew later. You're in the mode of power restoration. So this will be replaced later. Now let's watch the video.
Hey gang, welcome back. We just had a nasty line of thunderstorms pass through. I was on my computer doing some work and a bolt of lightning hit very close, within about 50-60 feet of where I was sitting. There was so much static electricity that a spark jumped between my computer and my finger. It took out my computer sound system as well as my wireless router. All power was lost inside the house, so I went outside, checked the circuit breaker, that was on. So I looked at the utility pole and I knew right away. You can see the switch is hanging in the down position. The circuit is open. We don't have any power flowing from the high voltage line at the top with the clamp into the transformer's primary winding. So I called up the utility company and they're sending somebody out to try resetting the switch.
Okay. So he starts, and I'm going to turn the volume up here for you. Maybe.
Hmm.
What do we call this stick? We don't call it a hot stick. What do we call it?
Phase stick.
No, sir. We're not phasing. We're closing in a fuse.
Oh,
Extension stick?
Extension stick. Okay. Be discreet, guys. A lineman's going to say to you, or you're going to be asking for something. Hey, I need a hot stick. Well, you got a shotgun stick. You got an extension stick. You got a switch stick. You got a short switch stick. There's multiple sticks out there. They're all hot sticks. But when you're asking for a specific item, ask for what you need. This is an extension stick. I could be honest with you, I've never heard of supply lines at 7620. You might have just not known exactly what that was.
I looked like some of y'all yesterday.
It must be a new guy.
Yeah. Uh-oh.
I see it. Okay, I want to tell you guys something here real quick. And it's the way in the placement of the stick, of the fuse in the fuse. Fuse in the switch. He didn't do it there. Go back a little bit more. Okay. I tell you guys, when you're putting the fuse barrel in a switch, to go ahead and go above the foot and drop down, correct?
Yeah.
correct.
Correct. Okay. I will let you know, gentlemen, this fuse will work in reverse also. I want you to get up here somewhere in the switch and drop down, and it takes a little bit of precision. If I take and bump the bottom of the barrel to the top of the switch, and this hits the bottom of the switch swaying in the wind,
Yep.
it will conduct electricity. Okay, so if you got a fault in there, or if you're picking up load, a good bit of load, this is a 50 kVA, do not touch the top of the switch with the bottom of the fuse barrel. I know the angle looks a little bit off, but I have seen linemen that have gotten directly under it, especially on a windy day, have accidentally hit the top of the switch, and the barrel right here, this all conducts, hits the bottom of the switch, and it's not a pretty sight. Get about midways, then drop down, which this guy does. Oh, come on, computer. There you go. I do not like that type of stick.
Yeah.
All right, get ready to listen closely. Okay. Did you hear the boiling that was going on there for just a, half a second?
Yep.
Yep, that's an internal fault to the transformer. This is why you guys, and we love to train you in this so much, not only for the preparation of you going for a skill set test, the guy actually here, I wasn't expecting that. I wish I left the camera on the tripod. After the second sound, the switch blew back in the lower position. The guy just pretty much hauled tail once that started happening, and he lost the camera. You do not want to be around this area and close to this transformer. If you're closing one, you don't know what the condition of it is. I've seen tops blow off. I've seen fuses explode. Why do we use an extension stick?
Stay away from
Keep us safe.
Give you the most amount of distance that you're able to get away from that transformer and fuse. Okay?
I got a question, Mr. Shoemaker.
Yes, sir.
Why did you say you don't like that stick?
See that hook that's on the end right there?
Yeah.
It gets caught up on everything on the planet.
Is that the only thing that's on the top of the stick? Is that what I'm saying? Just
No,
that
there
hook?
is. He's got this, and it is. I'll give it credit. If you want to take and put the bottom of the fuse barrel in this side of the stick, on this side of the hook side, it hopefully has more control and won't fall off the stick. On the other side, he has the same thing that we have.
Okay.
Okay. It might be my opinion, personal preference. I just don't like it.
I didn't care for him either. Boom.
And as you just saw, that was not very good. Went to reset the switch, you heard the sound it made, and it popped back down. That's an indication that the primary winding in the transformer is faulty. So what's going to happen next, they're going to send out a crew to replace everything you're looking at, the transformer on the right, the switch on the left, and that varistor or lightning arrestor that's damaged. It's all going to be swapped out. We're going to get it on film. Here you're looking at the new transformer on the truck. And you can see this one has a varistor built into it. The light.
Okay, so they brought a truck. This is actually not a truck. It's a mini derrick, so they can get in the backyard. Do you think it comes built this way?
No.
No. Okay, it's just going to come with a transformer. You on the crew are going to have to install the lightning arrestor and the wire that goes from the transformer to the lightning arrestor and eventually the switch. So transformers have to be made up, just like we're talking about in three-phase. They're going to have to be prepared on the ground and then sent up to the employee that's doing the work on the pole.
Lightning arrestor.
So this scares me a little bit. The crew requested that I not film the entire job because it will make them uncomfortable working. And they also had a concern that something they do may not be exact to training standards. And if a person from the company or OSHA sees this video, they could have problems. Instead, I will show a series of still images from the installation. I would suspect then that there's probably a problem, wouldn't you?
Yeah.
Yeah. This is probably one of the best statements I ever heard from our safety department or our supervision out there. Be prepared for OSHA or your safety team to visit you every minute of the day, every day of the week.
Yep.
You step out there on a job site and you start doing your work, think to yourself, if somebody stopped by OSHA or our safety department and looked up here, would they be satisfied? And when you've got that satisfaction met, you're good to go, guys.
Yeah.
Okay. If you have questions, ask your upper class lineman or your supervisor, what do I need to do here to make the situation safe? And when that is satisfied, you don't have to worry about OSHA. And you don't have to worry about your safety team coming out to do an inspection. You don't have to worry about the higher class lineman or your supervisor looking up at you saying, man, you're unsafe, you're doing something wrong. If you make it right to start with,
You're good to go.
you're good to go.
Yep.
This is backyard. It has to be climbed. All right, so what are you going to use here? Is the lineman, for one thing, that you see here on the pole, is the lineman allowed to climb the pole and install rubber goods by hand?
Absolutely. If you can't reach it with the truck.
What's he doing here? This is not a rubber hose. So let's go ask my first question again. Can I climb up there with my rubber gloves, have some hoses sent to me and cover up the primary from the pole? He's climbing it.
No.
He's
No.
using a
I
stick
mean, you'd want to use a stick.
No. Okay. What you're going to use here, and you can't stick rubber goods. You can stick what you see right here above what he's using, a line protector. All right. They come, and this is permanent. The stick, wooden stick that you see coming up here, this is what they call hard cover. And it is rigid. It's still rated to the voltage you're going to be working on, but you can install hard cover. My question here is, how did he get up this high to change out the switch? I don't know the answer. You're going to be in very close proximity. I don't know about a 7620. I'm going to say 7,200 volts. Okay. Now, Professor V, I'd like to get your input on this. If today,
Yeah.
if I had this situation, I would probably look at how many customers were on this entire tap line, and depending on the situation, that switch is extremely close.
Right.
I would probably de-energize all three circuits,
Yeah.
all three conductors. Would
Yeah,
you do the same practice?
Yeah, you don't want to just go up there and de-energize one phase that you're working on. You want to kill it all.
Yeah.
I mean, that's close. That looks like some of the construction we used to have.
Well, obviously, he has got to get shoulder to head high here. He's already changed out the switch.
Yeah.
He's got to get shoulder to head high right here.
Right.
And that is, guys, that's way too close.
Yeah.
Even if you have your rubber gloves on, your hard hat on, even if you're putting line protectors on it, that is
Yeah.
too close to the primary to be working. So I would de-energize all three conductors.
Yeah. And one more statement to that picture right there is he's doing it all wrong anyways. He should have started cover up on his side of the pole.
Good, good. And,
It moved away.
all right, yeah, we'll hold on to that. That's a good observation right there.
Yeah.
We'll stick with it. Professor V,
Yeah. Yeah.
as far as his location, where do you start installing protective goods?
Closest to you and then move away.
Closest to you. So here, then the furthest one away. How do you take it back off?
the same way you put it on. You go from furthest away than to you.
Back to you. That's in any cover up situation.
Yeah,
Cover up what's closest to you, move out.
yeah,
On removal, take the furthest one off, move back.
yeah,
That is a hard rule.
yeah.
Okay, this is a mini excavator. It's not a line truck. We'll talk about mini excavators later on. So he's got the transformer, and golly, I could probably chew this up. You know, they're not worried about the video, but
Uh-uh.
they're worried about it. They're not worried about, they are worried about a video, but then they're not worried about still pictures.
Right.
Tell me, is this sufficient as far as coverage?
Mm-mm.
Doesn't look like it.
No, really, the only reason he has this here is just in case somebody goes haywire with the boom of the line truck or the mini derrick. It's a mini line truck. No coverage over here on the side he's working on or center. No coverage on the opposite side of the pole over here. So really, this is just barely skating by. I would not allow this out
Uh-uh.
in the world.
No.
What's he leaning all over? What else?
Why?
Yeah. What else do we have to cover up? Not only the primaries, but what?
Secondary.
Secondaries and neutral. All right. He's got his body on it.
Mm.
That's a mini X. It really is meant for backyard line truck work.
Yeah.
Not a mini X, mini derrick.
And this is what it looks like when it's all finished. Brand new switch, brand new lightning arrestor. You can see the clamp for the high voltage line at the top. And this is a close-up of the lugs on the transformer.
Okay, so before we go here and take a break, we in the field, are we using, does anybody know what this piece of equipment is that's attached to the wire? Any guesses? It's what they call a stirrup. It's a stirrup just like cowboys, right? And this is not the type I like to use. All right, this is an old timey stirrup. But a stirrup itself is either compressed on or in this case, they're using two hotline clamps to attach it to the primary wire. Then the high side riser or the wire out of the top of the switch is attached to the stirrup. In order for us to do our workout at the training yard out there, if we have stirrups on our primary, it's just a bear to work with, for one, because you can't pull your wire up, you can't pull it down and sag it and do all sorts of things with it. But in real life, in real situations, if you're going to have something permanent out there in the world, you've got to install a stirrup and then put the hotline clamp in the stirrup. Now, who can give me a general idea why we use stirrups? Any kind of speculation, guesses? Is the hotline clamp in the stirrup, is that a connection point?
Yes.
I'm making connection from the primary down through that. Okay. If you have who's taking pictures? If you have a failure of this in this area because it's a connection point, you can heat up, or if you have any problems, if you have a failure here and it burns in two, how much power is lost?
Mm. Yep.
This goes to the transformer. How much power is lost if this fails?
All of it.
All of what?
All of the power is fell.
To what?
Everything that's going to that stirrup.
Everything that's feeding from that stirrup, right? We had a 50 kVA transformer there. You see the small picture. So if this fails and falls apart, all I'm going to lose is the 50 kVA transformer. If I take this and put it directly on the wire like we're doing, and it fails, what's going to happen?
It's gonna fail everything.
You're right. You're going to burn the wire in two, and the primary is going to go down to the ground, and everybody on this conductor is going to lose power. So I wouldn't call it isolation. It is a connection point that's going on right here that if you do have a failure, you're only going to lose what's at the connection. If you put it directly on the primary conductor, it's coming to the ground. So that's why we use Thuros. It's 10 o'clock already?
It is 9:50.
Good grief. Let's go ahead and take a break.
Okay.
And we will come back. Okay. If you want to go ahead and discuss that, I'll get prepared for the other part.
Right. Just about can. Give it another second. All right, guys, it's 10 o'clock. We'll go ahead and get back at it. You can see on my share screen here, I got a picture of a service bucket. This is identical to the one that I had when I retired. Professor Shoemaker showed earlier the picture of that little, we called them a backyard machine to get into tight places where you couldn't get a truck to. But I promise you I could get this service truck into many places where you wouldn't think possible. Sometimes you just got to do what you got to do. But this is a very versatile service truck. This is what all utilities I've noticed in our area, going to even HTC, they've got this same kind of service truck. And you can see up here, this allowed me to be able to change a transformer. It's got a jib and a winch and all up in here. Just a really good piece of equipment. You couldn't hang a big transformer with it, but you could hang up to a 25 kVA with it. It swiveled in a couple different directions. It would actually, this part would extend out. The little jib right here, you can see the back of it orange, and it's got a roller and the winch rope coming down here. This would actually, you could adjust this out probably 2 or 3 more feet out. And of course it had, just like on right here on this part of the jib, it had it on both sides where you could tell your weight limit of what it could lift. And you really didn't want to get it to the maximum. But that's a workhorse truck. The boom, the bucket, which is sitting down back here, it actually, when you lift it up in the air, you could actually rotate it all the way around and work off the other side of this boom. Very, very nice piece of equipment. Another feature Duke did with this truck, we were kind of getting away from hydraulics. So they're in this box, right? Not that box. There's another, it's supposed to be, I think it's this box right here. There's an inverter in there, and anything that we could need to run off electricity or charge our batteries for all our tools, that's what we used it for. But good truck. And if at all possible, you could, use this truck, I used it. I mean, it's very, very good truck. Professor Shoemaker, how about Santee?
No.
No.
And here's the direction I'm going on. First, I want to ask you a couple questions. What was the working height?
That very truck right there could reach to the top of a 45.
Really? A 45-foot pole. That's
Yeah.
kind of nice.
Yeah.
If you'll notice, HTC visited us the other day. The biggest truck they have, or as far as the working height, the tallest they could go was a 35. I mean, excuse me, a 40 on
Mhm.
one of these, and they really did not like stretching out that far. Now, we had this truck. We tried this kind of truck out, and please put your input in here. How many outriggers are on this truck? Professor V?
Two, I'm sorry.
Two, okay. So you got two right there where you got your mounts at, the upper cab area. To be honest with you, and I think it would go up to a 50 kVA, correct?
This one would do up to a 25.
25. Okay. Well, that makes more sense to me.
Yeah.
We had one that went up to a 50 kVA on the boom lift right there. But you know, working in backyards or working off shoulders of roads,
Yeah.
and I'll admit this to you guys, a lot of people were just sketchy,
Right.
if you want to put it that way, about
Correct.
picking up a load like that and not having the boom directly under the pole that you're working at.
Right.
So, you know, you're going to rotate off to the sides of the truck. You're going to rotate, or you're going to get the boom stretched out. And we were sinking the outriggers into the ground, even with the pads underneath them.
Yeah.
And the company kind of just got away from that. We did have one accident, not related to lifting a transformer, but we had a truck similar to this, and the guy parked on the shoulder of the road and had to reach across the road to replace a fuse. It was underwater in a swamp, so he couldn't really even get to it by foot.
Yep.
So he stretched the boom all the way out. He weighed about 270. The ground gave way and turned the truck over. So, and he was injured pretty badly. He went back to the company, but he was okay. So we as a company steered away from not this type of truck, but having the jib and the transformer lift capabilities on it. So it's just going to go to the company standard of, you know, what you're going to use and what you cannot use.
Yeah.
I think the safety aspect of it when we're talking with you guys is, if you, and this, you know, I told all my guys, you get in a situation where you're doing work and the thought comes into your head, I don't feel really too good about this. Guess what? It's not safe.
Yeah.
Okay. If you say, especially as being a new lineman, somebody asks you to step up a transformer and disconnect some secondaries on it, and you say to yourself, I'm not really 100% on that, then for you, it is not safe. Get instruction, go back, ask for assistance, confirm that there's no power on it, confirm that you got your truck, just get confirmations that you're doing everything okay.
Yeah.
So, you know, that thought creeps into your head, and I know it's crept into mine many times. Yeah, I can reach across this cross arm with my rubber gloves, grab that jumper and pull it back. I thought to myself, my whole upper arm is exposed. I don't have enough rubber goods on, but this one time it'll be okay. I know what I'm doing. No, if the thought came into your head, don't do it.
Yeah.
Don't do it.
Yeah. And that was one of the bad things of what you talked about earlier about this truck, was the body twist on it when you're going up. But this truck itself, because this boom is so beefy and it's so heavy, this whole back bed of this truck is aluminum. There's no steel other than the supports here and here, and in the back like that going across, other than the turret and this boom. Everything is aluminum on here, and I mean, just really would bend easy, and it had a lot of body twist when you would go over the side. So it could get kind of sketchy sometimes, like he said, you know, with their outriggers coming off the ground, or you felt like you were turning over. But also, I'll say this on the back, just like we do some bucket certification with Horry School District, they've got little degree bubbles on the back of each truck. And if it was anything over, I think 5 degrees, you weren't allowed to get up in it.
Right. There are the fleets nowadays that are coming out that will actually, the boom won't operate.
Yeah.
The boom won't operate if you've got too much of an incline that you're sitting on. The boom won't even go up in the air. That's a safety feature that's coming on.
Yeah. Yeah. So anyway,
Good.
love the truck, 4-wheel drive, but you notice it's got street tires, so you had to be careful where you go with these things.
Well, thank you very much. Any questions on that fleet? I know we're talking a lot of safety today, so I do have some stuff to talk about that's actually applicable to the 3-phase. So I'm going to do a share over here. Now there are work practices as far as, and we've talked about this once before. As far as manually handling, and I say you got to put some rubber gloves on, and you've got to work any type of voltage as a brand new lineman. Are you allowed to work any type of voltage when you first come into the company with rubber gloves? Take a guess. Yes, no, maybe so. I'm not grading you.
I doubt it.
There's
Whatever
one.
you're instructed to do.
There's no. There's one no. There's Santarella with somebody with you. Anybody else? Okay. Well, the answer
I would
is.
say,
Who was that?
Reggie.
Which say, Reg?
I would say no.
Okay. Yeah. The general practice is no. You're not allowed to work anything, and we got to remember the specifics I said to the question that's going on there. I cannot put on rubber gloves, and I cannot touch 120, a 120 line or a 7200 volt line. That is not allowed. But are you allowed to work voltages with a stick and rubber gloves?
Yeah.
There you go. Okay. You are allowed as soon as you're just going to take some supervision to first start off. You're allowed to stick anything that you want to. So if somebody says, well, grab that extension stick and open that switch up, you can do that because now you're using a 100 kV per foot stick. Follow the company rules. If they say you have to wear rubber gloves while using the stick, use rubber gloves. If they say it's not required that you use rubber gloves while you're using a stick, you don't have to use rubber gloves. Okay, different companies have different policies on that procedure. So I'm going to step over here to my 3-phase bank. And you might be in the instance where you're going to have to or close, that's energize or de-energize something that is 3-phase. Do I have a share up going?
Not yet.
Okay, stand by. This will apply to Delta and Delta only. So what 2 types of banks do I have here? Oops, wrong color.
An open delta. Where's delta?
And
And a closed delta.
closed delta. Okay, it's particular to these 2 banks. Which one's my lighting transformer on open delta?
Left.
Left. Which one's my power?
Right.
Correct. On closed delta, which one's my lighting transformer?
Middle.
One in the middle.
Middle. And which ones are my power?
And
The two on the outside.
2 on the outside, left and right. Okay. In open delta, the procedure is, Professor V, keep me straight here, just in case I go different by your procedures at Duke Energy. If this is energized, I need to open the power transformer first.
Right.
This is energized, I'm de-energizing.
Yes.
Open power transformer first. Then I open my lighting transformer second.
Same sequence.
Second. Okay. Anybody have any guesstimates to the reason why? Remember, in these cases here, I am disconnecting a load, a current load that's going into wherever it's going, Oliver's Restaurant. Why would I want to disconnect the power transformer first and then the lighting transformer second? Any guesses there?
Are you cutting off the biggest load first?
We're actually cutting off the lowest load first. Your thought processes are exactly where we wanted to go. All right. Your power load transformer is feeding, and especially in open delta, is feeding a lighter load. We'll say one motor. Okay. Once I have disconnected that, the load amount is going to go down a little bit. Then I'm going to disconnect the lighting transformer with the switch, and the rest of the load comes off. So it's a load reason that I'm disconnecting that. Okay. 2 is flip that. If I disconnect my lighting load first, which has the majority of the load on it, what will the power transformer try to do?
Try to compensate for that one?
Exactly. It'll try to compensate for all of the load, not only itself, but the lighting load also. You're either, if you pull off the lighting load first, you're either going to melt the fuse out because it's trying to pick up, remember, we got a tie-in bus going through here, it's trying to pick up all the load at once, or you're going to roast the transformer in the process. Professor V, anything you'd like to add there?
No, sir, that looked good.
Okay. So if it's power first, lighting second on de-energize, what is it on re-energize?
Go in reverse,
Which would be?
starting with your lighting.
Correct. You're going to close lighting first. Erase this part right here. Okay, back at it. So on re-energize, you're going to close lighting first, then close power second. Okay, just for the same exact reasons that you were talking about. Any questions there? You'll notice on this right here, I've drawn this especially for what's coming up next, and I'm going to need a bigger screen, so I'm going to erase part of this.
Mhm.
Open delta, is it floating neutral or is it grounded on the primary side?
Grounded.
Grounded. Okay, I actually did it twice. I grounded it here. I've got the tie-in wire and I grounded it here. All right, so let me start new. File, new. Don't save. Okay, I'm going to draw my closed delta. Okay, so I have riser. That's from my primary. Riser. That's from my primary. Riser from my primary. What do I do as far as grounding on closed delta? Do I float the neutral? Do I tie it into ground?
Float to neutral.
All right. I'll ask this. This came up before. On closed delta, this came back from the transmission lines when they use delta. They don't have a neutral. Why do I float the neutral? What's its purpose as far as three-phase is concerned? Does it share load between all three transformers?
It keeps all the transformers in sync with each other.
That when you say synchronization, you're right, very close to it. It's what they call load sharing, right? Remember, if I have 100 amps here, 150 here, and 100 over here, that's load imbalance. Well, what path does load imbalance follow? The neutral, correct? We talked about that before.
Yes.
So what's going to happen here is current flow is going to go this way, and it's going to go this way. That imbalance is going to go both directions. And then these two other transformers are going to help share this load imbalance is happening in the center. That's why we have a floating neutral on closed delta. Remember that. All right, so let's control Z, get rid of all this. Okay, what's the procedure as far as opening or closing transformers in closed delta? What is the step process? So we said we had lighting, we had power, and we had power. So what's the procedure as far as, and it doesn't matter left to right or left. Somebody let me know which transformer you're going to de-energize first.
The right power. Or the left power, and then the right power, and then go to the
Well, you just
left, and then the lighting.
different. It doesn't matter. You are totally correct. So you said right power, left power,
Left power, and then lighting.
then lighting. Okay. Now it doesn't matter here. I could go 1, 2, 3. I can go 1, 2, 3. As long as you're de-energizing both powers and then lighting last. Okay, lighting is always last for the same reason we did it on open delta. All right, you're dropping a little load, you're dropping a little load, and you're dropping the rest of the load. Okay, you're doing it in a step process. All right, hold. So other than Santarella, who's answering everything here, how do I re-energize this bank?
Start with the lighting.
First.
Start with the lighting. I think that was Reggie. 1. Next.
Then any of the sides.
Any other side. So you're gonna, I'll do this. 2, 3. Or 1, 2, 3 on closed delta. Everybody got that down? De-energize and re-energize. All right, Professor V, because you brought this up,
Okay.
I'm gonna go to ferroresonance.
Ooh. Boom, boom.
And let me know what you did on your system.
Okay.
Okay. Professor V had brought up before on closed delta. This is closed. Well, let me just talk about this real quick. I'm going to make this just so we have Y involved. For me to get my drawing right and make this Y, I'm going to come over here and Y.
Okay.
All right, I grounded the floating neutral. I have reconfigured my transformers to be AC, BD on my bushings.
Hmm.
So I've converted this to Y. Now, which transformer do I need to pull off first? They're Y, not delta anymore. First, do I have a lighting and power transformer Y scheme?
No.
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 So which one do you want to pull off first?
It doesn't matter, does it?
Thank you. Thank you very much. You know, I got the generic in my brain. 1, 2, 3. Left or right. I'm just going to pull them off in that direction. If you go the opposite direction, it doesn't matter. If you pull off the middle one first, it just doesn't matter. Okay. I've got no power transformer. Wow, that's good English. I don't have a power transformer. I don't have a lighting transformer. So it does not matter on Y. Okay, so let's get rid of this. So, and I'll go back to closed delta. I'm going to unground that. So Professor V had talked earlier when we first started getting into three-phase banks. He started talking about ferroresonance. There's tons of information out there in the world as far as ferroresonance is concerned in transformers. I'm going to condense it down so it's understandable for us as linemen and why we do certain things procedurally when we get in these situations of de-energizing and energizing transformers. All right, so we're back to closed delta. Simply put, if I follow the procedure of 1, 2, 3, all right, and energizing, that is correct. And if I follow, let me get rid of those, Z, Z, Z. If I follow the procedure of 1, 2, 3 in de-energizing, during that process, on closed delta and closed delta only, ferroresonance occurs. Simply put, when you have ferroresonance and I pull off any one of these transformers in this situation, doesn't matter the 1, 2, 3, 3, 2, 1, whatever the combination is, as soon as I pull off the first transformer, the other two transformers are going to have a voltage, what they call a voltage spike. And the voltage spike is from load trying to be compensated by the other two transformers. Voltage is going to try to compensate for the amount of amperage that was lost by this transformer. In order for me to compensate for the load, what does voltage have to do?
It has to go up.
It has to go up. It's going to try to raise itself as quickly as possible to be able to compensate for the lost load, because I don't have, there's no path to follow. I don't have it attached to ground, okay? If I raise the voltage, if the voltage raises up and spikes in these transformers that are still energized, it's going to go to the customer. We don't want that to happen. So, and this is where I'm going to need Professor V.
Yep.
There's a couple procedures that you can do here, and there's installations that are going to happen out in the world. I've not seen a picture of it yet. We started doing it many years ago. Let's see if I can get rid of this part. And draw this back in. So how many switches do I have? Few switches for these three transformers.
3.
1, 2, 3. What we did is either on the cross arm or we mounted it on the side of the pole, is we would put another switch here. See how well I draw a switch. We would come with a wire off the ground to the top of the switch, and guess where the switch would go to? Ground. Let's see if I can draw a cool fuse barrel right here. There you go. So in normal operation, day-to-day operation, I'm gonna do something different, guys. I don't like that. Just because you know the symbology.
Let's see.
We come off here. We come to here. Open. And we come down to here, ground. We all know right here that that's the symbol for a switch. In normal day-to-day operation, this switch would remain open.
Right.
And when it remained open, I would have a floating neutral. Okay. If I needed to de-energize or re-energize this bank, this switch needs to be closed. As soon as I close this switch, while I'm either energizing or de-energizing the switch, do I have a floating neutral? I'll restate that question again. When I'm energizing or de-energizing this bank, with this switch, draw it in, with this switch closed, do I have a floating neutral?
No.
Yes.
The switch is closed, it is going to ground.
So no more floating neutral.
Right, there's no more floating neutral anymore. I don't have it anymore. I closed my extra when they called it the fourth switch. So I have grounded my floating neutral. I re-enter, let's say I'm in the de-energized state. I close this switch 1. I open this switch 2. I open this switch 3, and I open this switch 4. I've added the 4th in there. That prevents, as soon as I close switch 1 and I take my path to ground, it's not floating anymore. All imbalanced load is going to go to ground, not to the other 2 transformers. So I've negated ferroresonance and voltage spikes. Professor V, before I get too much further.
Yeah, same thing with us. It's okay to open that bank up without closing in that ground and switch, but when you energize it, you better darn make sure you close that switch in first.
We did it both directions.
Yeah. Oh, really?
Yeah, we did it on the open or the close
Yeah, we did.
of these 3 transformers. We did it both directions. And that's, like you say, there's different company policies for different companies.
Right.
All right. So after 1, 2, 3, 4 on the de-energize, whatever we needed to do it for, say repairing secondaries or the customer wanted their power cut off for any reason, we would just leave switch 1 closed. On the re-energize, we would do what? 1, 2, 3, 4 would be the open.
Yes.
Because now I'm going back to normal operation. How many people have I confused?
You just went in reverse, correct?
Correct, yeah. Right, and that's really, when I did the energize and de-energize without the grounding switch, I did the same thing.
Okay.
Okay, I went 1, 2, 3. I didn't have the grounding switch.
Mhm.
Okay, for re-energize, and 3, 2, 1 for de-energize and didn't have the grounding switch. I'm adding the 4th location here to prevent ferroresonance and voltage spikes. Remember, closed delta only. And when I say closed delta only, it's the only one that has a floating neutral. I've got to disable that floating neutral when I'm energizing or de-energizing a closed delta bank.
Yep.
I remember the old days. You just send a lineman up there with a piece of copper and 2 hotline clamps on it.
That's it.
Yeah, just connect one and do your work, take it off when you were done.
Yeah.
The company got, and this is very good for observation rules. You know, not every single lineman's going to be doing this out there. Remember to do this. When you've got that 4 switch up there and see a 4 switch in that location, got it. I need to ground this bank before opening and closing it.
Yep.
Or ground the floating neutral. Okay, let's take about another 10.
Okay.
We're going to have a quiz review for today and get close to wrapping up.
Okay.
All right.
Questions? Continue on with your practicing until we get inside on the simulators.
Okay. I am going to introduce one thing tomorrow, first thing before everybody starts getting to roll, is using the shotgun stick. Shotgun stick is one of the tasks that's on your task list. We'll show you how to operate a shotgun stick and what it's used for. So that's going to be our new introduction for tomorrow, and practice on that also. Anything else, Professor V?
No, sir, none that I can think of. I think everything's good to go.
Okay, we will text you when the quiz comes available, and we will text you also when the video is complete and uploaded to YouTube. There are no further questions. If you want to hang around and talk privately, that's fine. Gentlemen, have a great day.
Yeah.
See y'all later.
Cameron, you drooling on your microphone? What was that?
I have a quick question.
Jacob Kisner. Jacob Kisner. All right, he is going to leave. Hold on. Where's allow him put in waiting room? There you go. Bam. James Rowland. Rolling. Come on.
Rolling.
Roland's probably putting his hair up in a ponytail.
Yes.
What's up?
What?
Hitting the line in there.
Are you done, Roland? Do you need us? Are you giggling?
Oh, I'm good.
Oh, you're good. Okay.
Have a good day,
No, I was
guys.
here